it matters.
12 years. Hey, I'll take it.
All right, listen up here. For 41, I believe the initial answer, this is where you have to use a substitution and you replace back in. 7 pi over 12 was one of them. And then when you first did it, you had negative pi over 12, if you did everything correct. And the interval is from 0 to 2 pi. That doesn't mean there's not a second answer. If you looked in the back of the book, there was a second answer. How do you get to it? If that's negative pi over 12, the period of that one is 2 pi. What you want to do, you want to add 2 pi to it. So you take negative pi over 12, negative, plus 2 pi, and that's where we get the 23 pi over 12. So if you looked at the two answers, one was, I believe, 7 pi over 12, and the other one was 23 pi over 12. So make sure that if your answer is not in that interval, that you either add or subtract 2 pi if it's sine or cosine, and it would be pi if you're tangent or cotangent for that one. So that was 41. I am going to do that example from the guided notes for 81. Bless you. To help go over that one, the one from the guided notes, and then that should help explain a few things. But let's just real quick, just make sure you're okay on 73 or 77. Let's do 77. Let me see one of these. And for 57, Caden, what did you get for 57? Yeah. Oh.
I didn't know where to go.
You said you didn't have any questions?
Yeah.
You just lied to me.
Yeah.
That's a big no.
All right. Dominic, what'd you get for 57?
I got 7 pi over 6, 3 pi over 2, and 11 pi over 6.
Are we on the same one?
No, is it 57 or 77?
57.
57, I got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.
All right, that sounds better. One thing I want to make sure you should get 4 answers. So you get sine squared equals 1/4. You take the square root, okay? And you got to put plus or minus in front of it. So plus or minus. So now sine of x will equal plus or minus, hold on here. The square root of 1/4, which will become 1/2. And so that's why you're going to get all the 30-degree reference angles, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So for 57, make sure you do that and you get both. And then you have to take the square root, I think for 73. So that helps. All right, 77, let me just write this one down real quick. 2 cosine squared x minus 3 sine of x minus 3 equals 0. Okay. All right, Sierra, you know what to do on that?
Yeah.
Explain.
All right. So you would make cosine squared x equivalent to 1 minus sine squared x.
Good. So it's good.
good.
All right, that's the big step there that you have to do is make that. Make cosine squared 1 minus sine squared. And now you got everything in terms of the same function, everything in terms of sine. Distribute the 2 minus 2 sine squared x minus 3 sine of x minus 3 equals 0. 2 minus 3 gives me negative 1. And since I explained last week, I like to have my first term positive, so I would move everything the other side or divide by negative 1. I get 2 sine squared x plus 3 sine of x plus 1 equals 0. And then factor that. And I believe they're both plus 1 plus 1. All right, once you get to there, hopefully you can set them both equal to 0, finish them from there. And then I get, what is that? 2 sine of x plus 1 equals 0. sine of x plus 1 equals 0, and sine of x equals negative 1/2. Sine of x equals negative 1. What do we get for sine of x equals negative 1/2? Tyson, what's that end up giving us?
So,
See if we agree.
I had 7 pi over 6,
Okay,
11 pi over 6.
okay, agreed. And then how about sine of x equals negative 1? Would that be 3 pi over 2?
Yeah.
All right, good. So make sure you replace sine squared 1 minus cosine squared. Go from there. All right, I'm going to go through the one from the guided notes, finish that off. And then I do have a couple more to do. You probably need your own paper. I don't know if you're going to have enough room on there for that. And then I'm going to actually add 81 back on the homework tonight. If you did it correctly, you should be good. If you didn't do it correctly, you'll be able to fix it. This is the one out of the book, so if you look through this, it should look familiar. One thing, remember, you cannot replace sine of x with 1 minus cosine of x. That's not true. And cosine of x does not equal 1 minus sine of x, okay? The squares do, but not just the linear terms. So you're stuck. You're stuck. So we need to make it something squared. So we're going to have to square both sides. So in here, I get square root of 3 cosine of x squared. All right, here is, you probably made, if you made a mistake, this is probably where it is. You got to put the entire right-hand side in parentheses and then square, which means you have to FOIL it. You cannot square individual terms. That is not true. Best way I can do to explain that. C equals A plus B. If you want to make if that is true and you want to make the claim, then I can just do that. C squared equals A squared plus B squared. Well, start with, say, 7 equals 3 plus 4. What happens if you square the individual terms? I get 49, I get 9, and I get 16. Well, what's 9 plus 16? So not 49. Okay. The only way that'll work, so if you got C equals A plus B, you can do this, but you got to do quantity squared. Then it'll work. Oh, what would that actually look like? So that, if I got 7 equals 3 plus 4, yeah, there we go. See? No big deal. So then you square it, it's going to equal each other. So you can't just square individual terms. You got to do the whole side. So that means right here, this is fine because there's no plus or minus in between the square root of 3 and the cosine of x. That's just a coefficient. 3 cosine squared of x. When you FOIL, you get sine squared plus 2 sine of x plus 1. Okay, now we're just going to do like we did on the last problem. You're going to substitute in for, in this case, cosine squared, and then we'll solve it from here. So we got 3 cosine squared is 1 minus sine squared. Sine squared plus 2 sine of x plus 1. Okay, go ahead and distribute the 3 and then move everything over to the right. So 3 minus 3 sine squared of x equals sine squared of x plus 2 sine of x plus 1. And when I move those over, that will give me 4 sine squared x plus 2 sine of x minus 2. We do have a GCF. You could solve this one without factoring out. I'm just going to factor it out just to make it a little bit easier. GCF of 2. And I get 2 sine squared x plus sine of x minus 1. All right, go ahead and factor the 2 sine squared x plus sine of x minus 1.
Yeah, because I like,
3 minus 1.
yeah, I brought it over, I think, breakfast.
Oh, you didn't give it 4. So you
Yeah.
did that without giving -4.
Yeah,
What do we get here? I get 2 sine of x. Sine of x. 2 sine of x minus 1, sine of x plus 1. Let's make sure that's right. All right, now split those up and set them equal to 0. 2 sine of x minus 1 equals 0. Sine of x plus 1 equals 0. Hey, what about that 2 out front? Do I need to worry about that as part of my answers? No, because it doesn't have a variable. If it was 2x, then that would give me another answer. Since it's just a constant, we don't need to, I mean, you can set it equal to 0, but it gives you nothing. Okay, that's no good. So that doesn't help us. Solving here, I get sine of x equals 1/2. Sine of x equals -1. All right, I believe we get pi over 6, 5 pi over 6, and then 3 pi over 2. Original problem, was it square root of 3 cosine of x equals 1 plus sine of x or sine of x plus 1? I know it's the same thing. Sine of x plus 1. All right, you run into an issue when you square both sides of an equation. Do you remember what that issue is? Extraneous solutions. You create a new equation which might have an answer that works for the new equation but didn't work for the original. So you must check your answers to see if they work, because they don't always work. So right here for pi over 6, you guys right here, you plug in pi over 6. See if it works. You can use your calculator, I don't care. You guys plug in 5 pi over 6. And you guys plug in 3 pi over 2. And you're just checking to see when it plugs in, if it works. All you're checking to see is the left-hand side equal to the right-hand side. Okay, if it is, if it doesn't, you know it's a solution. All right. Lizzie, did you check it? Solution. What are you waiting on? Oh, those of you need to finish those trig quizzes. We should have a little bit of time here today. Finish them. 30 seconds or something.
Okay, I should make sure.
Liz, you get it yet?
Yeah, it's just like R equal.
Oh.
Okay, I don't know. I must have been wrong.
All right, did you plug in pi over 6?
Yeah.
What's the cosine of pi over 6? That's a good question, isn't it?
That's a good question.
Cosine of pi over 6 would be square root of 3 over 2, right? Obviously. And then sine of pi over 6 is going to be
Oh, I don't know. 1/2.
There you go. I just want to make you feel a little uncomfortable here today. It's all right. 3 halves equal 3 halves. That's what I got. They work? All right, it should work. All right, Mason, how about 5 pi over 6?
It doesn't work.
Are you sure? No, it doesn't work. 5 pi over 6 doesn't work.
Yeah, I am sure.
You are sure?
Yeah.
Okay, so for 5 pi over 6, what you get is you get square root of 3 times cosine of that is negative square root of 3 over 2 equals sine is 1/2 plus 1. So you get negative 3 over 2 equals positive 3 over 2. So that one doesn't work. And then 3 pi over 2, hopefully you did get working. It should work. So 5 pi over 6 doesn't work. You need to double check your answers when you take something to an even power, squared, 4th, 6th. Okay, so just be careful there. All right, we're going to kind of work a little bit into section 6.6, which is really just an extension of what we've been doing. You'll look, the problems are essentially the same. Read the directions, write that down, and then just think about it for a second. And then we'll do it. Okay, again, I talked about the directions being important. Find all possible solutions for the following equations. Does it give you an interval? No, it does not, which means you're not going to list me just, a couple of finite answers. This is where you do like x equals 2 pi over 3 plus 2 pi n, or 3 pi over 4 plus pi n. You just keep it in the general form. Okay, you will not come up with the specific answers. Now, we're going to add, this is a little bit like 41 and 45 from the homework. You got something in the parentheses other than an x, so we're going to use substitution. So we're going to let theta, in this case here, equal 4x minus pi over 4. Okay, 4x minus pi over 4. And then I'm going to make this 3 tangent of theta equals square root of 3. All right, we need to solve for theta. Divide by 3. And I get square root of 3 over 3. All right, find the two angles between 0 and 2 pi that works for. You can use your calculator, that's fine. I would keep it in degrees just because it makes life easier for that, because it's hard to read the decimals. All right, what two angles? If you need your calculator, you can do it mentally, that would be great. I'm coming after you, so you do this right.
Uh-oh.
I'm happy with it. You can do that.
So you keep it radians?
That's one of them. All right, what quadrant's the other one positive? We're standing positive, first and third. All right, use that. That's going to be your reference angle. All right, 30 degrees and 210, which is pi over 6 and 7 pi over 6. I'm going to split this up for how I'm going to write this. So x equals pi over 6 plus, all right, what is the period for tangent? Don't forget, it is not 2 pi, but it is pi. So this is where we write pi over 6 plus pi n. And then he said the second answer was 7 pi over 6 plus pi n. All right, it's been a few days. I can't remember when we did this, but with tangent, something happens. Do you remember what happens with these two sets of answers? Okay, Dominic says he does.
Well, when we put in pi, we both get the same answers, pi 6 and 7 pi over 6, so it's repetitive.
You're going to get the same set of answers. Now, don't write this down, but like here, if I let n equal 0, you get pi over 6. And then when you add pi, whoops, you get the next answer would be 7 pi over 6. And when I add pi, I get 13 pi over 6, and then I get 19 pi over 6. And if I start at 7 pi over 6 and I add pi, I get 13 pi over 6, and then I get 19 pi over 6. So we said we essentially get what? The same set of answers, right? It just overlaps. So we don't want both of them. You don't want both of them. So throw out, keep, I guess, the smallest positive one. Keep the smallest positive one. We don't need that answer because it's equivalent to what we already have. All right, now I'm not done because what did we let theta equal? 4x minus pi over 4? Oh, that should be theta, not x. You guys are probably that's why you're looking at me funny. That should be theta. Sorry about that. All right. So now take out the theta and we put in 4x minus pi over 4 equals pi over 6 plus pi n. All right, we still got to get the x by itself. So add your pi over 4. Now you're only going to add that to the pi over 6 because the pi n is not a like term because it has a variable. You would treat that as a variable. So I get 4x equals. All right, what's pi over 6 plus pi over 4?
5 pi over 12.
5 pi over 12. So it's going to be 5 pi over 12 plus pi n plus pi n. But last step, divide everything by 4. And in this case, you do have to divide everything by 4. Just be careful here. 5 pi over 12, I'm just going to treat that as 5 12s divided by 4, which is 5 over 12 times 1/4, which is 5 over 48. What happens when you take a fraction divided by a whole number, and if you work this out, it's going to happen every time, is that you're really just multiplying that 12 and the 4 together. That'll take care of everything. When you invert 4, it becomes 1/4. So you get 5 pi over 48 plus pi n divided by 4, any integer n. So one set of answers for tangent and cotangent only. Tangent and cotangent only, one set. All right, I want to hit one more like that one. All right. Just talk to myself. Sorry. Talk to myself. All right, 2 sine 3x minus 3 pi over 8. We're taking the sine of something other than an x, so I'm going to use a substitution. I'm going to let theta equal 3x minus 3 pi over 8. And then I'm going to take 2 sine of theta equals negative square root of 3. Sine of theta equals negative square root of 3 over 2. All right, find your two angles and equals. And this time your period is 2 pi, so it'll be plus 2 pi n for both of them. So negative square root of 3 over 2, theta equals, it's going to be in quadrant 3 and quadrant 4. Should be in terms of degrees 240 and 300. In terms of radians, 4 pi over 3 and 5 pi over 3. So I got 4 pi over 3 plus 2 pi n and theta equals 5 pi over 3. 5 pi over 3 plus 2 pi n. All right, we've got to go back to our substitution. I got 3x minus 3 pi over 8 equals 4 pi over 3 plus 2 pi n. All right, add 3 pi over 8 and see what you get. 4 pi over 3. I'm going to go common denominator 24. Oh, okay. I see.
Did you get 41 pi over 72 pi plus 2 pi?
Yeah.
Two. The other one, no two.
Ty, what's 4 pi over 3 plus 3 pi over 8? What'd you get?
I got 41 pi over 24.
41 pi over 24. I agree with that. Plus 2 pi n. And then divide everything by 3. And I'm going to get x equals 41 pi over 72 plus 2 pi n over 3. Now the other one here, it's going to be similar to that. And I believe we get x equal, Jackson, did you get it yet?
49 pi over 72 plus 2 pi.
You're going to get 49 pi over 72 plus 2 pi n over 3. All right, if you don't get that, I'll have to come around and take a look. But those are your two answers. Do we need to list both of them?
Yes.
Yeah. Only for tangent, the only this one. This is two distinct sets of answers. Now I'm just going to make this a little bit nicer. 41 pi over 72 plus 2 pi n over 3. 49 pi over 72 plus 2 pi n over 3 for any integer n. All right, now we'll talk about these a little bit more tomorrow. You won't see one specifically like that on the homework. It's more some of the ones that like the factory and that. There are a good bit. Yeah. Sure. Don't let me interfere with you.
Is it so urgent?
Yes, sir.
Anybody else?
The equations are hit pretty hard on the test Thursday, so I want to make sure we go back and hit those. Read the directions. 32's in degrees. 40, you're going to have to put your calculator in radians, but then I would convert it right back to degrees. After that, just put it in radians, only when there's going to be decimals involved, which is that one. And then 81's there for, if you got it the first time, you should be fine. If you didn't get it, hopefully you'll spoil this time.
Why?
So I tried to read these and then I didn't get foil for some reason. And then I got it and none of them would work.
You feel good?
Oh, that's 81, okay.
No, you're good.
None of them work?
Yeah. And I'm pretty sure it's only